Hi, everybody. Welcome to TGCS. My name is Tim Gallagher, and today we are going to be discussing AP Computer Science A, topic 3.5, methods and how to write them. In this third video, we will develop code to define behaviors of an object through methods written in a class using primitive values and determine the result of calling these methods. We will also address initial conditions and some additional attributes of our method parameters. Let's get started. For this video, we're going to use a class called train. Train has an integer instance variable called capacity, which will represent the number of people that our train can hold. There may be other instance variables, constructors, and methods in this class that we're not going to focus on for the purpose of this video. We're going to write two methods of this class. First, we have a mutator method called setCapacity. This method will set the capacity of the train based on the number of people per car. Now, back in Unit 1, you learned about preconditions and postconditions. A precondition is a condition that must be true before the method is called. In this case, we have two parameters, people and cars. People represents the number of people per train car, and it must have a value that is greater than or equal to 0. Cars represents the number of cars that make up the train, and it must have a value greater than or equal to 1. The post condition describes the outcome of the execution of this method. In this case, our capacity will be updated to reflect the total capacity of people that the train can hold. As long as the precondition is met, we must guarantee that the post condition will be accurate. Our second method is getCapacity. This is an accessor method, and its post condition is that it returns the capacity of the train. So let's go ahead and write the code for both of these methods. First, let's look at setCapacity. We'll put our curly braces to indicate the body of this method. And we know that setCapacity is going to be a mutator method. It's public, it doesn't return a value, and it's going to be expected to change an instance variable using our parameters. So what should our code be? How can we use people and cars to calculate an updated capacity for our train object? Well, we know that the capacity represents the number of people that the train can hold. So if I update my people variable to be people times cars, well, now people will contain the overall train capacity. So now I can assign people to capacity, and our instance variable has now been updated. Now let's look at the getCapacity method. We know that this is going to be an accessor method. It's public, and it returns a value, which in this case is integer. So what should the code for this method look like? We should write return capacity inside of our method body. Remember, an accessor method always returns a value. Now that we've completed these two methods in our class, let's look at how we would use this class and these methods in context. Here we have a main method in a class that is separate from our train class. The first thing we're going to do is construct a train object called Subway, which creates our train object. Next, we'll create two local variables, numPeople and numCars, which we'll use as arguments in our method call. Now, let's call the setCapacity method on our Subway object and send it numPeople and numCars. This calls the setCapacity method in our train object, Subway. And we know what this method does. The people and the cars parameters are going to have the values of 50 and 10 from the variables that we defined in our main method. People is going to be assigned the value of people times cars. So people now contains the value of 500. Then we set the capacity instance variable to be equal to people. So now the capacity of our Subway train object is now 500. Finally, we have a call to our Subway method getCapacity within a println statement. This calls the getCapacity accessor method in our train object Subway. And we know that the code for this method will return the value of our capacity instance variable directly to the println statement that it was called from, which prints 500 to the screen. And now we've tested our two methods that we wrote for our train class. Okay, but let's go back and talk about preconditions for a moment. We know that the precondition for the setCapacity method is that people must be greater than or equal to 0, and cars must be greater than or equal to 1. But what happens if we violate that precondition? Let's say we initialize numPeople to be -20. Will this code still execute? Will this code even compile? It does compile and execute, and it prints a capacity of -200. Well, clearly, this is not a reasonable capacity. However, we violated the precondition, so we are not guaranteed that a reasonable capacity was set. It's very important that we are aware of the initial conditions that must be met in order for our code to work as intended. Let's reset our numPeople to a reasonable value. And let's look at one more aspect of calling methods with primitive value parameters. So we're going to add a print line at the end of our main method that prints out our numPeople local variable. We want to see if any changes occur to this local variable as our code executes. So when we run this code, we create our object to declare and initialize our two local variables. And then we call the setCapacity method on our subway. We know this sets our people parameter to 50 and our cars parameter to 10 in the setCapacity method. And when we multiply people times cars and store the result in people to calculate our new capacity, this changes the value of people to be 500. Capacity is also set to 500 when we assign people to capacity. But what happens to the original numPeople variable? This was used as an argument to set the capacity method to the setCapacity method, and we modified the people parameter. But does numPeople change because people was modified? Well, let's see what happens. 500 is printed out when the getCapacityAccessor method is called. And when we print out the numPeople variable, 50 is printed out, the original value of numPeople. So what happened? Why didn't numPeople change when we multiplied the people parameter by 10 inside the setCapacity method? Well, the parameter people received a copy of numPeople. Primitive values are copied when they are sent to a parameter. Changing the people variable had no effect on the original numPeople variable value. So in this video, we developed code to define the behaviors of an object through methods written in a class using primitive values and determine the results of calling these methods. We examined how preconditions can help define initial conditions that must be met for a code segment to work as intended. We also noted that when an argument is a primitive value, the parameter is initialized with a copy of that value, and changes to the parameter have no effect on the original argument value. That's it for this video. Thanks for joining us here today. Don't forget to hit that like button, subscribe to this channel, and we'll see you next time. Take care.